Welcome back. Today we're going to be talking about laws of exponents part 1. So let's go ahead and take a look at our first rule. So our first rule in exponents is going to be when multiplying powers with the same base, we're going to add the exponents together. So here we've got x to the third times x to the fifth. So we're going to be multiplying them. So we're going to be adding them because they have the same base of x to the third and x to the fifth. And if we look at that, that's like multiplying x times x times x for x to the third. And then for x to the fifth, we're going to be doing x times x times x times x times x. And then we're going to just be counting up our x's. So how many x's are all together? 1, 2, 3, 4, 5, 6, 7, 8. So that is simplified to x to the 8th power. Same thing with our y's there. We've got 1y for the first one times y to the third. So again, we're going to have 3 y's. So times 1, 2, and 3. So how many y's do we have all together? We're just going to add them up, and that's going to be y to the fourth. All right, down to the bottom, we've got x to the third, y to the second, z to the fourth. Then we've got x to the seventh, y to the third. All right, so we're going to only be combining the things that have the same base. So our x's have the same base, so there's 3 of them in the first one. There's 7 of them in the second one, so we've got x to the 10th there. Then we've got y to the second there, y to the third there. So 2 plus 3 is going to give us 5, so y to the fifth. And then the z doesn't have anything to combine with, so we're going to just leave that as z to the fourth. So our final answer there is x to the 10th, y to the 5th, z to the 4th. We can't go any further than that. They don't have the same base, so they can be combined no further. Let's go ahead and take a look at our next rule. So our second rule here is dividing exponents. Our rule is when dividing powers with the same base, we're going to subtract the exponents together. So in this case, we've got the first one has 8x to the 6th, so we've got 6 x's on top. 3, 4, 5, 6, and we've got 2 x's on the bottom. So we're going to cross out some to see how many we have left over. So we've got to cross off these, and we've got to cross off these. So we have 4 x's left on the top. So that's going to be x to the fourth. Now, same thing on the next one. We've got y. So we've got 3 y's on top. And we've got 6 y's on the bottom. So we'll write our 6 y's. 1, 2, 3, 4, 5, 6. And again, we're going to do some canceling. So we're going to cross off ones that we have some left over. So these are crossed off, crossed off, crossed off. And we have 3 y's on the bottom, but we have nothing on the top. We have nothing on the top. We don't have nothing. We have a coefficient, but that coefficient when we had y to the third was 1. We don't write that because we don't write a coefficient that isn't the number 1. So we have, or when it is the number 1. So we have number 1, y to the third. So that's going to leave us with a 1 on the top as our coefficient, y to the third power. Now down there at the bottom, we've got coefficients here of -8 and +12. When we do have regular numbers that are not exponents, we're going to treat them like regular numbers that we always do. So they're in a fraction form here, so we're going to be reducing them. So 8 over 12 can be reduced to 2 over 3. So we're going to start with our -2/3, negative because the negative is there attached to the 8. Then we're going to go about taking out the numbers that we normally would just following our rule. So we have p to the 10, p to the 7th. Since 10 is more than 7 by 3, that's going to go on the top. So we've got a p to the third power. Then we've got q to the second, q to the fourth. The q to the fourth is bigger, so on the bottom we'll have q to the second. And then we've got z to the fifth over z to the fifth. Those are going to cancel out because they're both z to the fifth power. They're going to cancel out to give us 0. So our final answer is -2/3, p to the third power on top, q to the second power on the bottom. Now let's go ahead and look at our next rule. Now our rule for exponents to a power is we're going to apply the exponent to all the values in the parentheses. So if we have values inside the parentheses, the exponent has to go to all of them. So our first one, we've got 4x to the third power. So that means that the third power has to go to both the 4 and the x. We have to do it to both. Now, a number is going to react the same way as it would normally. It's not going to be changing anything different. So 4 to the third power is still going to be 4 to the third power. So 4 times 4 times 4 for our expanded form here. And we're going to do x to the third power. So we're going to have 3 x's. So it's going to be times x times x times x. So when we write that out, 4 times 4 is 64. And x times x times x is the x to the third power. So we applied everything on the inside. Now our second one there, we've got x to the 6th over 4, and that's going to be to the second power. But again, we're going to take that exponent and make sure that we apply it to everything, both on the numerator and the denominator, because it's everything inside the parentheses. So we have 2x to the 6th on the top, so x to the 6th here, times x to the 6th here on the top, and we're going to have 4 times 4 on the bottom, because again, we've got 2 of each of the things. So again, we know we're going to have to apply our rule about adding when we have multiplying of the same base, so x to the 6th and x to the 6th is going to result in giving us x to the 12th on top. And then we've got 4 times 4 on the bottom, and 4 times 4 is just 16. So we've got x to the 12th over 16. Now the last one there, we've got a couple things going on. So on the numerator, we've got 72x to the 5th, y to the 3rd. No powers that need to be applied there. On the bottom, however, we've got 6x to the 4th, y to the 6th, inside the parentheses being squared. So before we go ahead about simplifying by subtracting, because we have things on the top and the bottom, we first need to apply the exponents. We have to use our order of operations and understand that exponents come before multiplication or division in this case. So we're going to take our second power to everything on the inside here. So we've got to distribute it to the 6, to the x to the 4th, and the y to the 6th. So 6 going to be 6 squared, so 6 times 6 is going to be 36, so that'll be on the bottom. X to the 4th squared, so x times x 4th and x 4th is going to give us x to the 8th. And then y to the 6th, so again 2 of those is going to give us y to the 12th. So that's everything that's on the bottom. Still on the top though, however, is going to be 72. And then we've got x to the 5th, and we've got y to the 3rd. So now we're going to apply our rules just like we had previously. So the good news is 72 divided by 36 works out evenly. That goes in twice, so that'll be a numerator at the top there. All right, then we've got to figure out, does anything else go on the top, or does everything else go on the bottom? So we've got x to the 5th, x to the 8th. The 8 is bigger than the 5, so it's going to stay on the bottom with x to the 3rd. We've got y to the 12th, y to the 3rd again. The 12 is bigger than the 3, so the y to the 9th is going to stay on the bottom. So our final answer there, 2 in the numerator, x to the 3rd in the denominator, y to the 2nd in the denominator. Now let's move on to the next example. So here we are at example A, and we've got to use all of the rules now that we've learned and try to apply them to simplify each of these expressions. Remember, we're not going to get down to just one number because we don't know what x and y are. Our goal is to only try and reduce as much as we can. So we've got numbers and we've got exponents with variables. You got to treat the numbers separately than the variables. Okay, so we're going to make sure that we're going to keep our numbers with our numbers and our variables with our variables. So we've got negative 3/7, x to the 4th, y to the 1st, times 2 to the 30th, x to the 5th, y to the 8th. So I'm going to start by multiplying the numbers. Now these are fractions, so you can use your Decimus calculator if you'd like, but I'm going to use some cross simplification to make my job a little easier. So I've got 3 goes into 3 one time, 3 goes into 30 10 times. Then I can see that 2 there is going to go into 2 one time, and 2 goes into 10 5 times. So now that I can just multiply across, 1 times 1 is 1, and 7 times 5 is 35, so I've got negative 1 over 35. So that's just the numbers portion of it. Now I need to focus on the exponents. So I've got x to the 4th times x to the 5th. So I know for my rules that means I'm going to add them because they have the same base. So x to the 4th, x to the 5th is going to give me x to the 9th. And now I've got to do y to the 1st because I don't see any other exponent here. So I know that's a first power. So y to the 1st, y to the 8th. They're going to add together to give me y to the 9th. And this is as far as I can go. This is my final answer. Negative 1/35 x to the 9th, y to the 9th. Now again, this is a fraction that we were multiplying together. So we're not trying to determine if x to the 9th goes to the top or y to the 9th goes to the bottom. Okay, because it's just a fraction. It's not that the exponents were part of a fraction. They were just being next to the fraction. Now let's take a look at example B. All right, so here in example B, we've got a problem where we've got powers being raised first and then being multiplied. So we have negative 2ab raised to the 4th power times 5a to the 3rd, b to the 2nd to the 3rd power. So again, we're going to have to follow our order of operations first. So we're going to use our exponents to begin with. So we've got to take care of that, everything being raised to the 4th power and everything being raised to the 3rd power before I can go any further. So let's go ahead and take our 4th power. So again, that means that everything inside the parentheses has to be raised to the 4th power. So negative 2 times negative 2 times negative 2 times negative 2 is going to give me 16. Then I've got a to the 4th power, so a to the 1st times a to the 4th, so we just got a to the 4th. B to the 4th power as well, because again, it had just a base of 1. Now on the other side there, we've got to go ahead with our 5 to the third power. We need a 5 going to the third power. We need a going to the third power. We need b going to the second power, but it's all going to be raised to the third power. So 5 times 5 times 5 is going to give me 125. A to the third power, so we've got 3 of those, so that's going to end up being a to the ninth. B to the second, we've got 2 of those, so that's going to be b to the sixth. So now that we've done everything to the power, now it's time to go ahead and multiply across. So again, we're going to multiply our numbers just as we normally would. So 16 times 125 is going to be 2,000. I'm sure we all knew that off the top of our head, but if we didn't, we can always use our Desmos calculator for support. Now we have a to the fourth and a to the ninth. Again, we're going to add those because they have the same base. We're going to end up with a to the 13th power. And then we've got b to the fourth, b to the sixth. We're going to add them together because they have the same base. So we end up with b to the 10th. So our final answer there, 2,000, a to the 13th, b to the 10th. Now let's take a look at the last example. Here we are at example C, and again, we're going to have to apply multiple rules in order to simplify this one, because on the numerator side, we've got to work with the a to the fourth, b to the third times negative a, b to the fifth, and on the bottom, we have a to the fifth, b to the 10th. So we're going to, again, use our order of operations, and we're going to go ahead and do the things across the top first, and then we'll simplify with the things on the bottom. So we first got a to the fourth and negative a. So the bases are still going to multiply together. So a times negative a is going to result in negative a because negative times a positive is a negative. Then we've got a to the fourth and a to the first. So that's going to leave me with a to the fifth. We've got b to the third and b to the fifth. So that's going to give me b to the eighth. And that's going to be our numerator. Our denominator is going to stay the same for the moment, so we've got a to the fifth there and b to the 10th. And now we're going to simplify using the rules that we know by subtracting the bases, or subtracting the exponents based on their bases. So we've got negative a and negative a to the fifth, positive a to the fifth. So in this case, they're going to cancel out. We're still going to be left with that negative 1. So that negative 1 is still going to have to stay there on the top, and we don't know what else will be joining it. Then we've got b to the 8th, b to the 10th. The 10th is going to be bigger than the 8th, so that's going to go to the bottom. So we've got b squared down at the bottom, and that's our solution, negative 1 over b squared. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.